Right, today let's talk about the electron arrangement in atoms. And up to this point, we've talked about electrons only living in an electron cloud, and then we expanded that a bit when we described Bohr diagrams, and those electrons lived in different energy levels. So let's start by reviewing some basic information. Specifically, we know that electrons live in the electron cloud, that they are basically massless. For our purposes in class, we say they don't have a mass, they don't have any appreciable difference on an atom's mass, at least in relation to the protons and neutrons, which are much more massive. Also, their charge, of course, is negative. We do know that electrons are responsible for chemical reactions. Specifically, those are the valence electrons, which are the outermost electrons. Now, atoms like to have either full valence energy levels are completely empty. So if you happen to be hydrogen or helium, you're going to go for a duet, which is completely filled with 2. Or if you're all the other atoms, you're going to go for 8 electrons. That would be completely full. So completely full or completely empty are stable configurations for electrons. We can start to talk about electrons in terms of different energy levels. So all atoms have multiple energy levels, whether they have electrons in those energy levels or not. And those energy levels have predictable numbers of sublevels and total, let's see how to say that, total electron capacities. So for example, energy level 1 has 2 total electrons in it, can hold 2 total electrons. And it would have valence shell of 2, and there's one sublevel. It's called the S sublevel. Energy level 2 happens to be able to hold 8 electrons, valence shell of 8, and then there's 2 sublevels here, S and P. Energy level 3 can hold 18 total electrons. It has 3 sublevels, S, P, and D, and then it has, again, 8 valence electrons. So here comes that octet rule that we keep talking about. Energy level 4 can hold a total of 32 electrons, and we have S, P, D, and F, so 4 different sublevels, 1 sublevel for each letter. And again, the valence electrons are 8. And when we get to energy levels 5, 6, and 7, we're starting to get into some theoretical atoms that we don't actually have at this point, but we can predict that they're there, and we can also predict that their energy levels and sublevels will be present. So even though energy level 5 only has 32, it could theoretically hold more than that, because there should be a G sublevel that's predicted by some of the theory that's out there. But we know for sure that energy level 5 has S, P, D, and F, and we can see that on our periodic table in a future lesson. Energy level 6 has 32 electrons, S, P, D, F, and G, and there should be something else out there. Same thing with energy level 7. But one common theme to see is that if you're in energy level 2, you have a duet. All other energy levels have an 8 for their valence shell capacity, the outermost energy level. So sublevels. We saw those sublevel names, S, P, D, and F. Those are the ones that we actually have as far as most of our atoms go that we look at. We don't go to G, even though it's theoretically predicted. We can see that the sublevels have different names. That S stands for sharp, P for principal, D for diffuse, and F for fundamental. And then each sublevel can hold a characteristic number of electrons. The S can hold 2. And that's because it has 1 orbital, and each orbital can hold only 2 electrons. The P has 3 different orbitals, so it can hold a total of 6. So in other words, 3 times 2 gets me to 6. D has 5 different orbitals. It can hold 10 electrons. And F has 7 different orbitals. It can hold 14 electrons. So S is a spherically shaped orbital. You can see right here. P I call propeller shaped. It looks kind of like a propeller. D looks kind of like a flower, so I call it daisy shaped. Or there's one that happens to be propeller shaped with a donut around the middle. So that's how I get the D donut, or D daisy, P propeller, S sphere. And then because there's 3 different versions of the P orbital, we can have 3 orbitals. This can be vertical, sideways, or the same shape can actually pop out of the screen in 3-dimensional space. And that's how we get to those 6 electrons, because there's 3 orbitals. 3 times 2 makes 6. There's 5 arrangements of this, 4 arrangements of the daisy, 1 of the P with a donut, giving us a total of 10. 5 times 2 makes 10, etc. So at this point, you should have reviewed basics of electrons, and then you should have a better understanding that electrons live in different energy levels. Those energy levels are broken into sublevels and then into specific orbitals. We have names for those sublevels, and we have shapes for the different orbitals. Hope that helps.